Hello everyone, this is a demonstration video for task 5.2D above and beyond credit. So first of all we are going to talk about it. What are we doing ahead? Like operation and handshake process in TLS will be the first part that we will look into this demonstration video. Then I will show you practically in the Wireshark how a three-way handshake takes place. Then we are going to look into some basic steps for email. And then we are going to look into security issues with ARP and Ethernet cables. Then to advanced networking concepts and more, we will look into the video as it progresses. First of all, I will going to explain you the operation and handshake process in TLS. So the TLS or the transport layer security is a protocol that provides secure communication between two applications over the internet. It operates on top of the TCP/IP protocol suite and uses cryptographic techniques to ensure privacy, integrity, and authentication. The handshake process in TLS involves several steps. First, the client sends a hello message to the server, which includes the version of TLS it supports, a random number, and a list of supported cipher suites. The server responds with a hello message, which includes its own random number and the cipher suite it has chosen from the client's list. The server also sends its public key certificate to the client, which the client uses to verify the server's identity. The client then generates a pre-master secret and encrypts it with the server's public key, sending it back to the server. Both the client and server use the pre-master secret to generate a session key which is used to encrypt and decrypt data during the session. So now I am going to perform this activity practically on the Wireshark.
Hello everyone, now we are going to see three-way TLS handshake using Wireshark. So now I have captured some packets from the website youtube.com, and as you can see in the Wireshark, this is a three-way handshake, client hello, and then some server hello, and then the application data will be received and the ciphertext chain cipher. So this is a three-way handshake. It is like I have explained through Wireshark. This is a practical three-way handshake. It is involving more steps, but in the Wireshark only these three steps are showing. So that's all for the three-way handshake using Wireshark.
So as you saw in the activity that I performed in the Wireshark, that how a TLS three-way handshake takes place. Hope you got a good demonstration of the process. Now we will look into the basic steps to send email from one user to another. To send an email from one user to another, there are several basic steps that must be followed. First, the sender opens their email client and composes a new message. They enter the recipient's email address in the to field and add a subject line and the body of the message. The subject line is not mandatory, but it is advised to keep it because the receiver will first see the subject line, and if a receiver is like an organization or a busy person, he can just skip your mail if your subject line is not attractive or doesn't contain any useful information. So once the message is complete and we have written the subject line and the body, the sender clicks the send button. When the sender clicks send, the email client connects to their email server using SMTP, which is also known as Simple Mail Transfer Protocol. The email server then forwards the message to the recipient's email server using SMTP. If the recipient's email address is valid, the message is delivered to the mailbox. The recipient can then open the message in their email client and read it. So now we will look into the next part, which is the security issues with ARP and Ethernet cables. ARP or Address Resolution Protocol is used to map IP addresses to MAC addresses in computer networks. However, it is vulnerable to security attacks like ARP spoofing, where an attacker sends fake ARP messages to redirect network traffic to their own device. This can lead to data theft or network disruption. Hence, it is important to implement network security measures like ARP monitoring and port security to prevent such attacks. Ethernet cables are used to connect devices in a network. There are two types of Ethernet cables: straight through and crossover. Straight through cables are used to connect different types of devices, like a computer to a switch or a router to a modem. Whereas crossover cables are used to connect similar devices, like a computer to another computer or a switch to another switch. It is important to use the right type of cable to ensure proper communication between devices. Now we will look into some advanced networking concepts, which are like the OSPF, BGP, and EIGRP. They are some advanced routing protocols used in computer networks. OSPF stands for Open Shortest Path First, and it is an interior gateway protocol that uses link state routing algorithm to find the shortest path between two nodes. And the BGP, or the Border Gateway Protocol, is an exterior gateway protocol that connects different autonomous systems and helps in routing traffic across them. EIGRP, or Enhanced Interior Gateway Routing Protocol, is another interior gateway protocol that uses distance vector routing algorithm to find the best path between two nodes. These protocols are crucial for efficient network communication. Inter-AS and intra-AS are two types of routing protocols used in computer networks. Inter-AS, or Inter-Autonomous System Routing Protocol, is used to connect in different autonomous systems and route traffic between them. Whereas intra-AS, also known as Intra-Autonomous System Routing Protocol, is used within a single autonomous system to route traffic between different subnets. These protocols ensure seamless connectivity and efficient routing in complex network topologies. Now we are going to discuss some application layer protocols in video streaming. Video streaming is the process of transmitting video content over the internet in real time. It requires the use of several application layer protocols including HTTP, RTSP, and RDP. HTTP is used to transmit video files from the server to the client. RTSP is used to control the playback of the video, allowing the client to pause, rewind, and fast forward, whereas RTP is used to transmit the actual video data, breaking it up into packets and sending it over the internet. These protocols work together to provide a seamless video streaming experience for the user. Next, we will look into stop and wait, go back N, and selective repeat. Stop and wait, go back N, and selective repeat are three different types of protocols. And there are like three different types of flow control mechanisms used in data communication. Stop and wait is the simplest mechanism where the sender sends a packet and waits for an acknowledgement from the receiver before sending the next packet. Go back N allows the sender to send multiple packets without waiting for an acknowledgement. But if an acknowledgement is not received, the sender must go back and retransmit all the packets from that point. Selective repeat is similar to go back N, but instead of retransmitting all the packets, only the lost packets are retransmitted. Each mechanism has its own advantages and disadvantages and is used in different situations depending on the requirements of the communication system. I have shown this like stop and wait and go back in the one of the activity that I did in during my networking and communication class. So now we will shift on to congestion control in TCP. Congestion control is the process of managing the flow of data in a network to prevent congestion, which can lead to reduced throughput and increased delay. The TCP uses several mechanisms to perform congestion control, including slow start, congestion avoidance, and fast retransmit or fast recovery. Slow start is used to gradually increase the amount of data being transmitted until the network becomes congested. Congestion avoidance is used to maintain a stable rate of transmission when the network becomes congested. Fast retransmit or fast recovery are used to quickly recover from lost packets without waiting for a timeout. These mechanisms are work together to ensure that TCP can operate efficiently in a variety of network conditions. What are the inter-AS and intra-AS routing? Inter-AS and intra-AS routing refers to two different types of routing within a network. Intra-AS routing refers to the routing that occurs within a single autonomous system, which we discussed earlier. The main difference between the two is that intra-AS routing is typically easier to manage and maintain since it only involves a single AS. Inter-AS routing, on the other hand, can be more complex and require additional configuration and management since it involves multiple autonomous systems. To end the topic, we are going to discuss some of the activities ahead of this topic, but the theory part will end here. So we are now going to discuss the straight through Ethernet cable and crossover Ethernet cable. Ethernet cables are used to connect devices together. There are two types of Ethernet cables: straight through cables and crossover cables. Straight through cables are used to connect different types of devices such as computer to a switch or a router to a modem, whereas crossover cables, on the other hand, are used to connect similar devices such as computer to another computer or a switch to another switch. Now we will look forward into some of the activities.
Video, I am going to show you the working of the Hello client, Hello server in the Python which I have created. First of all, we will run the server file. It is going to show something like this in the terminal. Then we will go to the client file and run it. As you can see, it is asking to enter your name. We can enter any name, like my name is Vibho, so I'm going to enter Vibho. Hello Vibho, welcome to SIT 202. Do you want to continue? On the server side, you can see name of the client is Vibho. It is getting recorded, so we can continue another time and type anything like anything MSD. So do you want to continue? It again showing. We'll say no this time and check whether on the server side it is showing MSD. Yes, it is showing MSD. So that was the server client application that I have created. So the code looks like this. I'm going to close the terminal. It first imports the socket module. It creates a socket object and it gets the local host name through this command host is equal to socket or get host name. Then it defines the port number 9999. Then it binds the socket to public host and a well-known port. So on the both sides we have defined the port, and that is same 9999, and the host we also define the local host. So it is getting bind to that host and port number. So we are printing waiting for client to connect, and it is entering the while loop in the server side. It receives data from the client and decodes it, and some data it encodes and sends to the client side. Same thing is happening. The encoding and the decoding process is happening here also. We have used if else to conditionalize the code. So if we want to continue, like I showed you in the terminal, then we have to enter Y, then, or if you want to cancel or go back, we can press N. So that was all. Hope you liked the demonstration. Thank you. Hello everyone. In this network, this is a Cisco packet tracer, and in this network I was asked to connect a fifth PC to the network, which already consisted of 2 switches and a router. So I decided to put on a third switch and connect fifth PC to it. We can basically just grab the switches from here, the downside, and the PCs also get tracked. So now we are going to check the connection of this from PC1 to PC5. We are going to ping. So we will double click on PC1. It will also work with single click. Then we will go to desktop and to command prompt we are going to type ping 198 right 168.1.3, which is the like IP address for the PC5 which I have configured. Oh, it's unreachable. I guess it's showing some error. You check the IP address again. 1 second. It's the IP configuration. It is 198.168.24. Sorry, I just entered the wrong IP address. Now we will try again. 198.168.2.4. Now it shall work correctly. As you can see, now it is connecting and the reply is receiving. So that was all for the Cisco packet tracer, in which I connected a fifth PC to the existing network of 4 PCs with 2 switches. Thank you. Now we are going to see DHCP packets using Wireshark. For that, we have to disconnect our Wi-Fi and connect it again. But first we need to start the Wireshark packet capture. We can see that no packets are getting captured. Now we are going to connect the Wi-Fi. As you can see, the packets are loading. Now we'll stop and search in this filter bar for the DHCP. Now you can see the DHCP request and acknowledgement. Just simple. Though there are many other steps involved like DHCP discover, request, acknowledgement, but those processes are not, those like messages are not getting showed in the Wireshark. So we can just see the request and acknowledgement. So that was all for the DHCP part for the 5.2D.